Our next speaker is Anushi Khandare, and she comes from University of Leeds and will talk about assessing the placement of air cleaners in a multi-zone hospital ward to reduce infection risk using content modeling, energy and cost analysis. You ready?
Uh, Hello, everyone. This is Anushi from University of Leeds, and my PhD topic is evaluating the performance of air cleaning technologies for mitigation of infection risk in hospitals. And today I'll be presenting just the initial part of modeling of assessing the placement of an air cleaner using contam modeling. That's the energy and cost analysis of a 12-zone hospital ward. So as we all know that COVID-19 has increased the need for understanding proper ventilations and having good air around us. And as humans spend most of the time indoors, it's really important to have good air in spaces like schools, hospitals, offices, buildings. And the maximum risk of catching an infection is in a hospital where there are maximum number of immunosuppressed people, and not only the patients, but the doctors, the healthcare workers, the staff, everybody is in the risk of catching these infections. Therefore, to cater to this, the air cleaning technology provide an excellent solution to reduce the infection risk in hospitals. There are a number of air cleaners present in the market currently, like the ionizers, electrostatic precipitators, UVCs, HEPA filters, but the HEPA filters are the ones that are mostly recommended for using in a hospital. So my PhD is basically in two parts. The first is modeling, and then it's experiments in the chamber and real world experiments in an actual hospital ward. The first part is modeling using contam modeling. And this is the 12-zone hospital ward that we've used. So the entire Contam model has been taken from work done by Alex. Probably he's not here today. And what we've done is we've incorporated air cleaners in this 12-zone ward. And previously, what we did was we changed the infector position. Like the infector moved from one place to another, and we tried to see how the concentration of the pathogen changes when we uh, change the infector position. And we created various scenarios by infector position and the ventilation rates. Like we have natural ventilation and a mechanical ventilation of 3 ACH air changes per hour or 6 ACH. So now what we've done is we've had the similar ventilation patterns, but we've changed the number of air cleaners used and the placement of the air cleaners. And we've done an energy and cost analysis for this. And we've also calculated the risk index of how the risk changes in all these different scenarios. So the air cleaner that we used was simulated to run on three different speeds, and the power required for these devices to run on three different speeds was given by our industrial partner AirSentry. And the simulation period for this was 7 days, like the entire the it was run for 168 hours. And with simple calculations, we calculated the energy that's required for the air cleaner to run on three different speeds. And using the cost that's required per kilowatt per hour, we calculated the cost that's required for the device to run on three different speeds, with the cost coming up to 0.43 pence for running the device on speed one for 7 continuous days, which is quite less. And we also calculated the energy for mechanical ventilation of 3 ACH for the entire ward, which came around 160.57 kilowatt per hour. And for 6 ACH, it was 321.14 kilowatt per hour, which is quite high as compared to that what we require for an air cleaner. And for calculating the risk index, so what is risk index? It's basically a term for to understand the infection spread in an environment. And it's a concept that's used to compare risk, and it was calculated as the ratio of the total number of exposures to the total number of susceptible people in the entire ward. So the three scenarios that we've created is a single zone air cleaner model where the infector was present in zone 5 and the air cleaner was also present in zone 5. The second scenario where the air cleaner was present in all occupied zones, that is what I showed in the previous picture, where just the corridor, there were no air cleaners, and zone 9, and the infector was still in zone 5. For the third scenario, we placed the air cleaners in all 12 zones, and the infector was still in zone 5. And for all the three scenarios, we did run it on three different ventilation patterns. The first one being natural ventilation, the second one transient natural ventilation plus 3 ACH, and the third one being transient natural ventilation plus 6 ACH. So when we look at the results for the first scenario, where the air cleaner and the infector being in zone 5, for natural ventilation, with the air cleaner not present, the number of exposed people was 6. And with the addition of an air cleaner and running it on speed 1, the exposed people reduced to 50%. That's from 6, it reduced to 3. And the cost required to do this was just 0.43 pence for 7 continuous days, which is quite less than £1. When we moved to natural ventilation plus 3 ACH and an air cleaner in zone 5, without an air cleaner, the exposed people were 2. And with an air cleaner, it reduced to 1, 1, and 1 for all three different speeds. And the cost required was quite high as compared to the previous case of just natural ventilation. And when we add in mechanical ventilation of 6 ACH, for speed 2 and speed 3 it reduced to 0, which is actually what recommended in a hospital. For 6 ACH is actually recommended in a hospital, is what I'm saying. Yeah. So scenario 2, where the air cleaner was placed in all occupied zones. With speed 3, we see that with £25 weekly, the exposed people reduced from 6 to 0. Similarly, for natural ventilation plus 3 ACH, for speed 2 and speed 3, it reduced to 0 with approximately £50, 50 to £70 weekly. And for natural ventilation plus 6 ACH for all three different speeds, it reduced to 0. But like again, mechanical ventilation also plays a very important role, and that was also responsible for reducing the infection risk. But combination of both is what recommended. For the third scenario, where the air cleaner was placed in all the 12 zones, we see that with just £10 weekly, the number of exposed people reduced from 6 to 0. For natural ventilation, it was 0, but the exposed people was 0 with approximately £45 to £80 weekly. And for three different speeds, 6 ACH, the number of exposed people 0 with approximately £85 to £125 weekly. So this was the highest cost that we had because the number of air cleaners had increased. And in the first one, the natural ventilation, we see that with just £10 weekly, we could reduce the number of exposed people to 0, which is actually looking at from a cost and energy perspective. This is the best case scenario that we have in all the three different cases. While also comparing the concentration of pathogen for all, this is a comparison for all three scenarios for the natural ventilation case. We see that the concentration kept decreasing as scenario 1, 2, and 3 because the number of air cleaners were increased. Similarly, for 3 ACH and natural ventilation, for all three scenarios, the concentration of pathogen decreased. And this was also this was also the concentration reduced as compared to the previous natural ventilation case. And for 6 ACH, this was the lowest concentration that we had in all the scenarios. And we also calculated the risk index, where we saw that as we increase the natural ventilation plus 6 ACH was the case where we had the least risk index. But as we see that the risk index for natural ventilation plus 3 ACH, scenario 2 for three different speeds. For speed 2, it was approximately 0.015 which is quite less as compared to what the risk was without an air cleaner. Therefore, coming to an end, um, air cleaners are successful in reducing the risk in almost all the scenarios, even in the absence of mechanical ventilation. And as most of the hospitals in UK do not contain mechanical ventilation, retrofitting is actually very, very expensive for them. The best case, I was able to produce the least amount of exposed people while also keeping in mind the cost aspect and the energy aspect, was that of scenario three, placing the air cleaners in all 12 zones and running it on speed two, which costed around £10 weekly with 40 kilowatt per hour energy consumption and the risk index of 0.015. So, although this approach actually requires the initial capital cost is quite high for this, but the long-term operational cost for this is quite less as compared to retrofitting an hospital. And in conclusion, it's just that air cleaners should be placed in spaces where mechanical ventilation is not present, or even if it is present, a combination of mechanical ventilation and air cleaners is what is recommended. Thank you.
Thank you, Anushi. Let's go next door. We have a question here.
Hi, Jack Bartlett, Cohort 6 at Imperial. Do you have a measure for the uncertainty in these results? For example, can you measure the variation when you perturb the initial conditions?
Variation for the infection risk or?
Yeah, for all of your results, really.
We have not calculated the uncertainty as of now, but yeah, that's something we can think about. And also, like, we have in mind the validation of these results using experiments, so that is how we plan to compare.
Great talk, Anushi. Army University of Manchester. I was wondering, so the running cost is not the only important thing, it's also the maintenance cost. How often the filters needs to be changed if they use the cleaners?
So it's obviously not monthly. It's maybe like 6 to 7 months that you change the filter, and the filter price and the running cost of an air cleaner compared is very, very less as compared to retrofitting and HVAC in a hospital.
You've got an array of air purifiers you can use. So the one you tested here is just HEPA filtration.
Yeah.
Do you have an idea of how picture might improve if you use other types of air purifier?
So for hospitals, HEPA are the one that's recommended. I think if we try UVCs, UVCs do not remove pollutants, they just remove like microorganisms. So maybe like a combination of them would be the best. But like, yeah, HEPA filters is what is there for hospitals.
That question here.
What's the exchange rate between the different zones depend on the number, the location of the impact to exist and you use?
So you mean the interzonal rate in the zone?
Exchange rates between the different zones you would have.
Yeah, so that is already accounted for in the contam model that we've used, because the model is that accounts for natural ventilation, mechanical ventilation, interzonal flows, and the position of the infector as well as the occupants. All of that has already been incorporated, and then when we add an air cleaner, it basically acts as a sink in the contam model, and then the interzonal flows change according to that.
CFD calculation of?
See, we've not used CFD for this. We've just used contam model, but
Well, mixed model in each zone?
yeah.
From natural ventilation, is it a reliable model?
Sorry, for natural ventilation.
Natural ventilation, knowing to know if the well-mixed zone model is variable.
So this is one of the limitations because it assumes that it's a mixed model, and that is one of the limitations for contam modeling.
Thank you very much.